Okay, today we're going to multiply polynomials and just making sure that we know all the verbiage here. What a polynomial is, poly means many, and I just think about many terms. Okay, so these right here, this is a polynomial, and so is this. And to be more specific, this is a binomial because this is two terms. And so is this, two terms. So today we're going to multiply a binomial times a binomial. And what I use is algebra tiles to show this, because that's the picture that I need to have in my head. And I'm going to try to transfer that knowledge into kind of like a chart so that it makes more sense to me and I know that I didn't miss any pieces. Okay, so the first thing that I do is I write across the top and across the side my two terms that I'm multiplying. Now, of course, you know in multiplying, we can only multiply two terms at a time. So here I go. I'm going to multiply x times plus -3. And I'm going to multiply that by x plus 4. Now x minus 3, x plus -3, same thing. It just looks a little bit different. I like to tell my students that it's kind of like a makeover. And so what I know, and I need to introduce, are my algebra tiles. So I'll bring these guys over. This is x squared. And the reason why this is considered x squared is because the length and the width of this square is both x. Like, we don't know the value of the length, so we just name it x. And so x times x we know as x squared. Okay. This is considered a positive x, and I'll be using this and this and this as a positive x, and this and this, how do I go back, as my negative x, if that makes sense. I'm going to put them right here. And this is going to be considered my positive one, and this is going to be considered my negative one. And so these are basically my tiles. So this is the x squared term. The reason why this rectangle is considered x is because it has the same length right there as the x term. But how thick it is the same unit as 1. Oops, I don't know if you can see that. It's the same unit as 1. So this is x times 1, and this is a 1 times 1. So that's considered our unit. So there's my algebra tiles. I actually have physical pieces of these in my classroom that I use and have my students use. And so, all right, so now we're just going to multiply these things. And this is called the area model because we're going to find the area of this rectangle that is x plus 4 long and x minus 3 wide. So there's my big blue x squared place. Okay, so x times x is x squared. So he goes right there. And then x times 4. Okay, so x times 4 is 4 x's. So we're going to grab these guys. And we need 4 of them. So here's 1, 2, 3, and 4. And then I'm just going to kind of like line them up so that they fit really nicely. And 4. Okay, so there's 4 x's. Let me count again. 1, 2, 3, 4, because 4 times x is 4 x's. Does that make sense? 4 x's. And then x times -3 is, what is it? All right, good. It's -3x. So here's 1. And how many of these do I need? Oops. I need 3 of these. So 1, 2, 3. I just line them up here. And I kind of leave a little space, and I do this in my class too, because when they get all like together like this, we can't really see how many we have if it's not labeled correctly. So I kind of space them out so everybody could see how many there are. There's some more space there. Okay, so we have x squared. X times x is x squared. X times all the way over here 4 is 4x is 1, 2, 3, 4. And x times negative 3 is 1, 2, 3, negative 3 x's. And then the last piece that you're missing, do you see this little hole here? Is negative 3 times 4, which is negative 12. So then negative 12 goes in here, and I usually just write it all in, but I'm going to show you with all these tiles just to make sure it is negative 12. And the reason why there's 12 of them is because 3 times 4 is of course 12, and then, but why is it red? Why aren't they yellow? Why didn't I grab those yellow tiles? Oops, whoa, went a little crazy. I didn't grab those yellow tiles because it's not positive. So a negative times a positive is a negative. Alright, there you go. So there's my answer. Now, if I was to write out my answer, it would look something like this. And I would just have to add like terms together. And so help me remember how to put like terms together. So does the x squared have any like terms? No, because he's the only x squared. So here we go. Here's my x squared. And then this is 1, 2, 3, 4 x's. So plus 4x. Down here I have 1, 2, 3. I have 3 x's, except those x's aren't positive, they're negative, so I put in minus 3x. And then I've got these 12 down here. Notice it's a 3 by 4 rectangle, and they're negative 12 units. So if you notice, these are the only like terms we got right here. So what I'm going to do is I'm going to add them together. So I've got x squared, I'm going to copy him because no one changes, and I got minus 12, minus 12, can't write for some reason, minus 12 back here. So what is 4x minus 3x? So over here, if you look at these guys, right? If I line these up, what's x minus x? Right? That's a zero pair. So a positive one and a negative one make 0. So if you notice, these two match up, these two match up, and these two match up. So think about these 3 canceling these 3. So all I'm left with is this positive one right here. So my answer over here is going to be plus x. And if you want, you can write plus 1x, just so we're all on the same page. So x minus 3 quantity times the quantity of x plus 4 is equal to x squared plus 1x minus 12. Okay. So there is my example of how I do it with tiles. So in the next video, I'm going to show you how to incorporate how to use this without bringing all these clunky tiles everywhere. Because what we want to do as mathematicians, we don't want to use these tiles every single time. We just want to use this as a foundation to understand where all this math stuff comes from. So there's the foundation of it. So when you're thinking of x times x, think about that big blue square. And x times 4, think about these little green rectangles. And then same with these red rectangles, except for now they're negative, right? And so here's my little 12 because that's 4 times negative 3. So all you got to do is line it up. So if you want to try this same concept using tiles again, why don't you try a problem and maybe make it look something like how x plus 2 times x minus 5. Okay, practice this and use the tiles, and then make sure to watch the next video and understand how I then transfer it to a different organization so that it makes more sense. Okay, this is kind of like part 2 in my multiplying polynomials video here. And in the first one, we talked about how to multiply polynomials using tiles. And now I just want to continue and transfer that knowledge and just kind of use how we got this and transfer it to what I call over here my box. And usually my box isn't this big, but we're going to use it right now. So what I do is I want you to understand and classify this information kind of like that. Oops, let's scoot them over just a tad. And so if you notice my box, everybody's kind of separated into there. This times this, this times this, this times this, and this times this, and in this area. And so now what I want to do is, now that I understand and I have the foundation of why everything is kind of like why this piece is here, why this piece is here, why this piece is here, and this piece, now I want to take that information over here and I want to do what I call the box. And let me just kind of draw my box first. So first thing is I just draw a box, and because it's a binomial times a binomial, now that's a 2 by 2. Let me finish drawing this and then I'll show you my two pieces that I'm talking about. So because there's two pieces here and two pieces here, notice there's two boxes this way and two boxes this way. And again, I'm gonna right across the top, we're gonna go x plus 4. And I like to keep the plus right there, and then the x minus 3, and again keep the minus right there so I don't forget who's who. And so what I do is I just copy all this information over here. So this is the x squared term here, so that's x squared. And if you remember from our last video, that's because x times x is x squared, and therefore x times x is really x squared. So what we're doing here is we're using the tiles in our head, but we're just writing down how many pieces go here. Okay, so let's continue. What's 4 times x? We wrote 1, 2, 3, 4 x's. So again, we'll write 4x here. So let's try this without the tile. Pretend you're not looking at the tiles right now. What's x times negative 3? It's negative 3x. And what about 4 times negative 3? It's negative 12. If we really did this right, then these two boxes down here, these two stuff that we filled in here, should match what we have down here. So do we have 1, 2, 3, negative 3x? Yep, we do. And do we have 3 times 4 is 12, but they're all red, so that makes it negative 12. So the same information is done over here, except for now we're doing it with a box without the tiles. And so all we did is we just said this times this to get what's in here. To fill in this box, we look all the way up and all the way left. And so this is called the area model, or these, you know, the science teachers at my school call these Punnett squares, and so it's really just an area model, with this being the length of the height, and this is the length of the base. So x times x is x squared. The area of this rectangle right here is supposed to be x squared. 4x, negative 3x, and negative 12. So a really great organizational tool, because if I gave you a trinomial over here, trinomial 1, 2, 3 times the binomial 1, 2, all you're really doing is adding more squares to this piece here. So, and then we do the same thing. X squared, 4x plus 4x, negative 3x, minus 12, minus 12. And notice again, we just have the same like terms. They appear here and here. And then there's our answer. So now what I'd like you to do is I'd like you to try the same exact example that I gave you the last time, except for this time, try using the box and see if that makes more sense. So that's my example on using the box to multiply polynomials, and I really like it because you're not restricted to a binomial times a binomial. And I hope you understood this, and if you have any questions, comment and I'll try to answer back.